Hello everyone, in this video we are going to see the concept of classical problems of synchronization. Actually, what is the problem of synchronization is if two or many processes wanted to communicate with each another, they have some communication media, that is through one technique is the synchronization. So, we have to see some examples of the synchronization problem. So, we have generally three problems. One is the reader-writer problem, and next one is the consumer-producer problem, and the next one and the third one is the dining philosopher problem. What is producer-consumer problem is, as long as the producer cannot produce anything, the consumer cannot consume. That is one type of synchronization. For this program, for this example, let us see the short codes of program, how the producer code looks like. So, while true is an infinite loop, it goes on happening. So, actually what they does is, they just produce the value and put in the buffer, and that is buffer of the input, that is equal to next produce. So, when any item is produced, it is produced and it keeps on adding to the buffer one by one, and the buffer is assumed to be a circular buffer. So, that is what this in is equal to in plus 1 percentage buffer size is here. That means once actually there are 5 is a buffer capacity, after 5 data is produced, for example, so 6th data is actually 5 plus 1 modulo 5, that means again it is the first one. So, likewise this counter plus increments the counter by 1 by 1, that means producer produce something, put in the buffer size and increment the counter. The counter keeps on increasing as long as it is equal to the buffer size. So, once the buffer size is over, the consumer start consuming, and the producer can keep on producing as long as it is the value is equal to the buffer size. When it is more, when the buffer size is exceeding, or when the data size is exceeding, the producer cannot produce more data. So, that is what this part of the program says, the producer side. Next one is the consumer side. The consumer is really the opposite one. We are just here, the while loop is the infinite loop, where the next consumed is the buffer of out. There we have seen buffer of in, that means putting inside the buffer. This is buffer of out is taking out of the buffer, that means we are consuming some data. So, that is equal to next to consume. Then out becomes out plus 1 percentage buffer size. This is the concept used in the circular buffer. When the buffer is circular, when you wanted to get the data n after 1 means, that is, this is the logic always given to get the data in the circular buffer. And then counter is decremented because consumer consumes, it takes out. So, it is a decrementation process. So, this is the coding in the consumer side. Okay. And then the same is as is usual with the writer and the reader also. So, writer is the like a producer side and reader is like the consumer side. So, they are both are similar problems. And now here the third is the dining philosopher problem. What is this dining philosopher problem says that there are, for example, here 5 philosophers are, they are sitting in a dining table to have their dinner. So, actually they always keeps on alternative thinking and eating. Okay. If at all they never talk with the neighbors, they keep on thinking and eating. If at all they want to eat, they need both the chopsticks from the either side to eat to have their dinner. So, when they want both the chopsticks, in the sense, for example, here, for suppose this philosopher want to have the food, he has to get the chopstick from this chopstick as well as this chopstick. That means this philosopher must not be using this chopstick and this philosopher must not be using this chopstick. Then only both the chopsticks are available for this particular philosopher. So, this is one type of synchronization problem. This philosopher should get both the left side as well as the right side chopstick. That means this second and here nth philosopher must be thinking, because they cannot eat. If they are not eating only, they will leave the chopstick to the side. That time when both are not eating, that means when both are thinking, that means they are not eating. So, they are left the chopstick without using. So, this center philosopher can use both the left and the right chopstick from the both the sides, and he can have the food. So, this is the concept of this this dining philosopher problem, which says about the synchronization between how to use this chopstick in the left and the right side of the philosopher. So that was the data. This is what explained over here. And now here the coding part is given over here. This coding is done using the monitor. So monitor is one technique that is used in the mutual exclusion problem, okay, that helps in the synchronization. So you can see the monitor, dining philosopher, so enum, thinking, hungry, eating. There are only 3 possibilities, okay. So they may think, they may eat. If they are thinking, they may in the hunger state. So we are having 3 states: thinking, hunger and eating. As you know, enum, the first will have the 0th value or first value, and that means thinking is equal to 1, hunger is equal to 2 and eating is equal to 3. So that is what the enum actually assigns the value. So state of 5, that means this is for all the 5 philosophers. So each philosopher may be in thinking, hungry or eating state. So it is given for state of 5, means 5 philosophers states. So each philosopher state may be one of these 3. So condition is again, what is the condition of this? A self of the condition may be these 3 conditions, okay. Now void pickup int I. So pickup is the function which helps to pick up the chopstick from the either side, and put down is the function that helps to put down the chopstick on either side. So for that, when they will pick up, when they are in the hunger state. So state of I is equal to hungry, and then test of I. What they will test? They will test whether the neighbor is in the waiting state or in the eating state. So they will check if state of I not equal to eating. If they are not equal to eating only, they will be hungry, they can start eating. So they will pick up the chopstick. And self of I is equal to wait. That means they are waiting to get the chopstick. If they are hungry, they are waiting to get the chopstick, and they are not in the eating state, okay. Then void put down. What is put down function states that when they will put down, when they stop eating only, they will start thinking. So they are in the thinking state, they will put down the chopstick. So that may be, they will put both the left and the right chopstick. So for the left it is I plus 4 modulo 5, and for the right it is I plus 1 modulo 5. So likewise, pick up help to pick up the chopstick, put down help to put down the chopstick. Next we will see the remaining part of the program, how the testing is done. How the testing is done? We are testing whether the either side, state of the I plus 4 modulo 5 not equal to eating, and state of I equal to hungry, and state of I plus 1 modulo 5 not equal to eating. So that means both are not eating. Left side person is not eating, right side person is not eating, but the current person is hungry. This is the AND condition for these states. If all these conditions satisfies only, state of I can become eating. So when they say you want to eat, they can give the signal. That means the signal actually passes the message to pick up the chopstick, okay. And then this is about the test function. Then next one is the initialization code. So initially we assume that for all the philosophers, for I is equal to 0 to 4, that is 5 philosophers, they are in the thinking state initially. After that they will go to the eating state or hunger state. Accordingly their turn comes, okay. So this is how the problem of synchronization of choosing the chopstick from either side is one example of the classical problem of synchronization. Hope you understood the concept behind these classical problems, and thanks for watching.